In this example, we're going to take this quadratic function, g of x, which is written in standard form, and we're going to evaluate it at 4 separate values of x. You'll notice we have a nice integer here, a fraction, a decimal, and this irrational number over here that contains the square root of 13. So we're just going to step through this one at a time and evaluate. So let's start with x equals -2, which means we're going to evaluate and say g at -2 equals, and we're going to plug in this -2 for every one of these x's up here. So we have -3/4 times, and we have -2 squared minus 3/2 times, well, that -2, and then we're going to add 1/3 to that on the end. Okay, let's see what we get. So when we're evaluating these quadratics, this exponentiation, it's kind of higher on the order of operations food chain. So we'll do this first because that's more important or higher precedent than the multiplication or the addition or subtraction that might take place later on. So we're going to have -3/4 times, well, -2 squared is -2 times -2, so that's +4. And for now, we'll just kind of bring the rest of this stuff along for the ride. Okay, well, here it looks like this 4 could go over 1. Well, it doesn't really matter. Those 4s are going to cancel, leaving me with -3. We have minus and a negative here, so these two negatives, since they're being multiplied, will end up being a positive. And once again, we'll see that the 2's cancel, so we're going to end up with +3, and then plus that 1/3. Well, that's really nice because those 3's cancel, and I'm just left with 1/3. So I can say that g at -2 evaluated to +1/3. Of course, I can make an ordered pair out of that, and that ordered pair will be the input value, which is my x, and my output value, which is my y, and so -2, 1/3. All right, so let's go ahead and do the next one. So we're going to do x equals 8/3 in this case. So we'll do g at 8/3. And so lots of fractions in this one, I suspect. So -3/4 times 8/3 squared minus 3/2 times 8/3 plus 1/3. Okay, lots of fraction action. So once again, we'll do the square business first. We'll square the numerator and square the denominator. So -3/4 times, looks like 64/9 minus 3/2 times 8/3, and then plus 1/3. Okay, so we could use a calculator, but this really isn't that bad, so we'll just kind of work through it. So the 4 and the 64 will end up being, what, 1 and 16, that's going to be 1 and 3, so -16/3. Here the 3's cancel, the 2 and the 8, 1 and 4, so -4 plus 1/3. Well, that's nice. These two together are already over 3, and in fact, when I add them, -16 plus 1 will make -15/3 minus 4, but 15 over 3, I can reduce that to just -5 minus 4, so that'll be -9. So actually, that didn't come out too badly at all. So I can say g at 8/3 will equal -9. Or once again, I can write that as an ordered pair. So 8/3 -9. And there we go. So there's the second one. So let's go ahead and now look at our decimal that we're going to use to evaluate. So we're going to use -0.5. So we'll say g at -0.5, and that will equal, and we'll just write everything down, plugging in our -0.05 in for our x's. Okay, and so sometimes it might be easier to make this into a fraction, because since we have kind of a mixture of fractions and decimals, or you could make all the fractions into decimals. The problem with that is we have this 1/3, which will be a repeating decimal, which that's kind of a bear to work with when we are trying to add and subtract and all this stuff. Okay, so it'll be -3/4 times, well, -0.5 squared is -0.5 times -0.5, which is 0.25, which is a quarter. So really that's just 1/4. And then we have -3/2 times, well, 1/2 plus 1/3. So we'll just go ahead and change everything into fractions. Since most of our coefficients, well, all of our coefficients are constant, they're all fractions anyway. Okay, so this looks like -3/16 plus, looks like 3/4 plus 1/3. Okay, so between 16/4 and 3, it looks like I can get a common denominator of 48. Okay, so this one will be times 3. This one will be times, what, 12? And this one will be times 16. So -9 plus 36 and then plus 16. It should come out to be, what, 43 over 48 for that guy, which if you made it into a decimal, it would be a repeating decimal. So we'll just leave it this way. So we can say G at -0.5 will equal 43 over 48. Or in fact, we can make that into an ordered pair, and it will be -0.5 and then 43/48 for that output value. So input output is our X and our Y. All right, for this last one, because we're doing this irrational number here, the square root of 13 over 3 minus 1, we'll probably need another piece of paper because we don't have a lot of room left on that one, and I suspect this will take up some room. Okay, so let's rewrite everything. So our X value here is going to be that square root of 13 over 3 minus 1. So we're evaluating G at this value, and so let's go ahead and plug everything in. We have -3/4 times the square root of 13 over 3 minus 1 squared minus 3/2 times that value that we're plugging in, and then plus 1/3 on the end. All right, this might look like, oh my, but we'll be okay. So when I square this stuff, I'm just going to go ahead and put them side by side and multiply them out just so we can kind of visualize what's going on. Okay, so here we go. So let's focus on the multiplication here first. And it looks like it'll be 13 over 9 minus the square root of 13 over 3 minus the square root of 13 over 3 plus 1. And that's just FOIL, or the distributive property, however you have learned that previously. All right, let's keep going. So we can simplify what's in here a little bit more. So it looks like 13 over 9 plus 1. Well, that's just going to be, what, the 1 turns into 9 over 9, so it'll end up being 22 over 9 minus, let's see, 2 radical 13 over 3. All right, so let's distribute here and here, here and here. And so we can reduce some stuff here. So the 3 and the 9 can go to 1 and 3. And so I'll make that a 3. I'll kind of cross that out as a 1 because we still need to use that 3 over here. And that guy will go to 2, and that guy will go to 11. So it looks like we have -11/6 when we kind of work that all out. Plus, let's see, the 3's will cancel, and we'll have the square root of 13 over 2. Okay. And then this distribution, the 3's will cancel, so negative radical 13 over 2. Let's see, plus 3/2 plus 1/3. All right, well, this positive radical 13/2 and the negative radical 13/2 cancel out, and so I have -11/6 plus, and let's go ahead and get common denominators. I can multiply by 3 on top here and 2 on top here, and I'll get -11 plus 9, which is -2, plus 2, which is 0. That actually came out really nicely. So what that means is that this square root of 13 over 3 minus 1 is going to be a 0, or a root of our function. So I can say G at the square root of 13 over 3 minus 1 equals 0, or I can write that as an ordered pair, as we have been doing. My input value, or my X, and then my output, or my Y, which is 0. So here was this original problem again. I'll kind of just Put it back in the camera view. So here is our original function, and here were the 4 values that we evaluated.